All right, started late because I forgot to record. All we did was a definition for domain and range. Now, I want you to look at number 1, and we're going to identify the domain. What's the domain of number 1? -4 to where? -4 to infinity. Why? What do you put around -4? Why? So, it's a parentheses, it's a whole, but based on the definition of domain. Why is -4 not in the domain?
It's a hole. It's an open.
So, based on the definition, what's the definition? Yeah, the x value of -4 does not have a y value that goes with it. What about the range? What's the range? -infinity. Remember, read bottom to top when you're doing range. -infinity to where? Is 5 a member of the range? Does the y value of 5 have an x value that goes with it? No. Number 2. What's the domain?
The domain is -infinity to infinity.
Is 1 included in the domain? Does the x value of 1 have a y value that goes with it? No. Because you see an open circle or a hole. Is that all of the domain?
No.
What else?
1 all the way to infinity.
1 to infinity, right. What's the range? -infinity to where?
1.
You got a hole. Oh. I don't know what I left out. You're my keeper of the recorder thing, okay? All right. Is -3 included? No. To where? Infinity. We are not going to do all these. Let's do number 4. We're going to do number 4 and number 6. We'll skip 5. What's the domain on number 4? Why don't you include -1? Does x equal -1 have a y value?
No.
No, so it's not in the domain. And? I heard -1 to 5. Does 5 have a y value that goes with it? Nope, so it's not in the domain. Good. What's your range? -3 to where? -3 to 3.5. Anybody agree? Look right here. What's the lower limit on your infinity? I mean on your fiddle. What's the lower limit on your range? -infinity to where? Roughly 3.5. Does the y value of 3.5 have an x value that goes with it? No. You do number 6. What's the domain? All reals? All right. There's some x values, there's some weird stuff happens. What about x equal -1? Is -1 included in the domain? Yes, because I got a y value down here. Is x equal 2 included in the domain? Does x equal 2 have a y value? No, because it's a vertical asymptote. Does x equal 4 have a y value? No. X equal 4 does not have a y value. So, what's the matter? I said there's a vertical asymptote there. And remember, a vertical asymptote means your graph is going to get closer and closer to it, but will not touch it.
Okay, so it's not.
X equal 2, no, a vertical asymptote's never a part of your domain. So you told me the domain is negative infinity to 2, open, and 2 to 4, and 4 to infinity. Well done. What'd you get for your range? Negative infinity to infinity, all reals? You sure? Okay, I got a y value. Where are my y values down here? Oh, yeah, they're included here, right? Where's my y value here? Yeah, over there. Where's my y value right here? Yeah, over there. Yeah, good. All real numbers. You can get some graphs drawn where you really have to stop and think about the domain and range. Speedy quick right here. Analytically means using algebra. What's a constant function? F of x equals c, so f of x equals 1. F of x equals 4. What's that look like? What kind of line? And don't tell me straight. Every line is straight. It's horizontal. It's horizontal. Remember, f of x is another name for y, so that means y equals. So it's horizontal line. So what I want you to draw here, I just want you to draw a horizontal line. What's the domain of a horizontal line? Yep, domain, all reals. Yep. What's the second one look like? Y equals ax plus b. It's, okay, could it be a horizontal line? Yes, because a horizontal line, what's the slope of a horizontal line? 0. Could it be vertical? Is a vertical line a function? What's the definition of a function? Every x has exactly one y. If I give you a vertical line, don't draw this, but I want you to think about it for a minute. If I give you a vertical line right there at x equal 2, the x value of 2 has a y value of 0, and a y value of 1, and a y value of 2, and a y value of 3, and a y value of 4. That's not a function. When you see this notation, we are talking functions. Every line is a function except for a vertical one. So I'm good with you drawing a horizontal or a diagonal line here. What's the domain? Yeah, all reals. Yep. F of x equals a times absolute x minus b plus c. What's that look like? That's a v. Now, how do you know if the v points up? What's negative? What negative? If a is negative, your v opens down. If a is positive, your v opens up. That's an example. What's the domain? All reals. What's this last one? ax squared plus bx plus c. That's a what?
It's a parabola.
That's right, it's a parabola. How do you know if the parabola opens up? Good, if that leading coefficient's positive, opens up, leading coefficient's negative, opens down. What is the domain? Do you notice, look, all of those, the domain is all real numbers. Now, when we get to the second page after lunch, here's what we're going to do. We are not going to talk about those kinds of functions that we just looked at. We're going to talk about some other stuff, and we're going to talk about what is the domain and range, but we're going to fly through this. We are not going to do all of this. We don't need it. Rational functions, hang on, are the ones that have asymptotes. So we'll spend a little bit of time there. Enjoy your lunch. A rational function. Remember, a rational function means you got variables in the denominator. That's all a rational function is. Based on your, wait, have I skipped? I skipped something, didn't I? That one, that's better. Given below are the graphs of 3 different functions that we will investigate analytically. Refer to them as you complete the table. Okay, listen, we are not going to do all of this. You do not need it. There's a row for each of those 3 functions up there. And the one that I want us to look at the most is this one. So I want us to take a look here. First of all, what's the domain of that function? Negative infinity to where? Is 5 included? Okay. Now, find the indicated value. What's g of negative 4? Well, it's 5 minus negative 4, right, 3. What's g of 9? What's g of 9? Undefined. Why? Because you cannot take a square root of a negative number. Now, let's talk about what those 2 answers mean with the graph. Look at this result right here. Pretend you can't see the graph, even though I know you can just look at it. What does this tell us about something that appears on the graph? Can you come up with anything that this tells us about the graph? Anything that's on the graph? What point? That's exactly what it tells us. It tells us that the point negative 4, 3 is on the graph. Negative 4, 3. Dun, da, 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 right there. What does this tell us? That what's not? For what? There's no y value for what? For, well, what does this tell us? It tells us that 9 is not in the domain because it has no y value that goes with it. We just made the conclusions. So the conclusions are the point negative 4, 3 is on the graph, so negative 4 is in the domain. 9 is not in the domain because 9 has no y value. If you want to explore the other 2 that we're not doing further, I will have the notes posted. Next page. Now we'll talk about a rational function. To determine the domain of a rational function, what you have to figure out is, where is my denominator 0? Here's the deal. H of x, which is our denominator, h of x cannot equal 0. Any place that that denominator equals 0 is not going to be in the domain, because that would make the fraction undefined. Am I saying anything you don't understand? I want you to look right here on number 1. What x values are not in the domain of f? X equal 3 and x equal 1 are not in the domain. Those are the only 2 numbers that are not in the domain. So can you write the domain of that function without looking at the graph, just by knowing this? X cannot equal, I need to put a not equal. X cannot equal 3 or 1 because those 2 x values make the fraction undefined, which means they have no y value. What's the domain of that function f then? Negative infinity to 3. Is 3 included? Nope. Now hang on. Let me do this. This might help. Let me make a number line. Here's 1 and here's 3. So negative infinity to where? Negative infinity to 1 and 1 to 3 and 3 to infinity. There you go. That's it. You don't have to see the graph. Take a look at number 3. Indeed, you do have to factor. Go. Do you have to factor the numerator if you are just trying to figure out where the fraction's undefined? No, you just need the numerator. You just need the denominator. How do you factor this? 2x and x plus 1? Minus 3, I agree. What x values make that undefined? 3 and what? Right. So if x equals 3 or if x equals negative 1/2, what do I know about that function? That function's undefined. Either one of 2 things is going to happen there. What are those 2 things? You're either going to have a pole or a vertical asymptote. So these numbers cannot be in the domain. So let's write the domain. What's the domain then? If these numbers have to be left out. To where? To negative 1/2 and negative 1/2 to 3 and 3 to infinity. See, finding domain's not so bad. The only domains that are going to screw you guys up are on a square root. And I don't know why, but it just always happens. So let's practice right here for a minute. You can only take the square root of what kind of numbers? Positives, or you can take the square root of 0, can't you? Sure. To determine the domain of a square root function, what's under the square root sign must be greater than or equal to 0. So we look at number 1 and we say, all right, what's the domain? What's under the square root sign? X plus 3. What do I know about x plus 3? It has to be greater than or equal to 0. So what would x have to equal? Or what would x have to be? Greater than or equal to negative 3. Do you remember how to graph that? Oh, how would we do that? How would we write it with interval notation? Negative 3 to infinity What goes around the negative 3? A bracket, because x can equal negative 3. Talk about transformations for just a second right there. What transformation happens to the square root function? Left 3. Look, that's why the domain is negative 3 to infinity. What about number 2? How do you calculate the domain? Perfect. Do it. I left that blank. What goes there? Y less than or equal to? Good, because when you multiply or divide by a negative number, the inequality has to switch. Do you know why? Well, by golly, you're going to learn. Here's the why. You agree with that? That's a true statement. What if I multiply both sides by 4? I get 4 and 12. 4 is less than 12. What if I had multiplied by a negative 4? Then I'd have negative 4 and negative 12. Which one's bigger? The only way to keep the sentence true is when you multiply or divide by negative, you got to change the sign or you don't have a true sentence anymore. Enough. Next page, cube root functions. Is this the last page of these notes? Okay. A cube root. We did not talk about a cube root. If you look, and you can just look up here, if we go back 2 pages, this is what a cube root looks like. Now this one has been shifted left 3, but that's what a cube root looks like. What's the domain of a cube root function? All real numbers. I can only take the square root of numbers that are 0 or bigger. Can I take the cube root of a negative number? Give me one that I can take the cube root of easily. Negative 1. What's the cube root of negative 1? Negative 1. Don't tell me negative 9. How about negative 8? Negative 2. Good. I can take the cube root of a negative number. Okay. What conclusions can you make about the domain of a cube root function? What's the domain of a cube root function? Domain of a cube root function is going to be all real numbers unless something wacky happens. And on one of these, something wacky happens. Which one of these has something that you think might be wacky? The fraction. What's the domain of the first one? Let me ask you a question. What happens to the cube root function? What transformation does the cube root function go through? Right 3. Nothing changed, just went right 3. Now this has some wacky stuff, but it's not going to change domain. Now I want you to look at this one. Why in the world would this one give us issues? Well, I've got a cube root.
But there's a fraction here.
So why is there an issue that I have a fraction? The denominator cannot be 0. Look at what you are taking the cube root of. You are taking the cube root of x minus 3 over 2x plus 1. That's called a rational function because you got a variable in the bottom. And in a fraction, the denominator can never equal 0. What x value makes this denominator 0? Negative a half. That is the only number that has to be left out of the domain. So x cannot equal negative 1/2. So how would I write my domain if that's the only number that it cannot equal?
Negative 1/2 not included, and negative 1/2 infinity not included.
That's it. That's it. Just trying to get you just a little bit more confident in your domain and range, but primarily domain. Let's see what you remember. Snap, finally. Does anybody remember what a composition is?
What it's based on. I feel like Mr.
Mr.
Stanby taught us.
Stanby? Yeah. He didn't teach, wait.
We had him for eighth grade in algebra.
Oh, gotcha. Have you ever heard anybody refer to something called fog or goff? Okay. I won't call them fog and goff, but it's a composition. Now, let me remind you why somebody might call it a fog or a goff. If you see it's an open circle now. And if you see that, that's why some people call it fog. The more common way, and the way that you will see it in pre-calculus or AP calculus, is you will see it like this. I agree. These mean exactly the same thing. F of g of x. Now, I am going to be totally stupid doing this, and you're going to think your teacher is an idiot, and that's fine. F of g of x. I need you to understand what that means. Does anybody know what that means? What's it mean? I plug g of x into f.
Yeah, that would be your x.
So what goes in first?
Your g of x.
Okay. So which function do you do first? Why? Because you go inside out. Now, I need you to think of a function as a machine. Now, if you are an artist, just think, oh, she is so pitiful, because this is my function called g. Don't, I know. Now, g is x plus 2. I'm making that up. And, here is my machine f. Yeah, I know. That's so sad. That's so sad. It looks like a cactus that's been chopped off. F of x is x squared. Now, if I do this, what it means is whatever I put into g is going to get this done to it, right? And that's going to pop out. But that is what's going to go into f, right? And that's going to have this done to it. And then what pops out is my answer. Now, in Algebra 1, here is how I teach this. And Brooklyn's going, yeah, she's an idiot, because she's heard this. What if I put in 3? Now I put in 3. So I cram 3 into my machine, and my machine goes, rah, 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 rah. Remember that? Yeah. My machine goes, rah, rah, rah. And what comes out? 5. What goes into F? 5. And 5 goes into F, and F goes, rah, rah, rah. And what comes out? And 25 comes out. That's what a composition is. The output of the first one is the input of the second one. Huh? So my x goes in, and the g of x comes out, right? And then the g of x goes into this one, and f of that comes out. And that's what a composition is. You ever tell a college professor I've shown you that, and you think I'm an idiot? Go ahead. So, I just need you to understand what a composition does and where it starts. You start inside. G is the domain, okay? G is what you put in, crap. X is what you put into G, right? X is what you... Sorry. X is the input into G, and the output of G is G of X. But that is the input into F, and the output is F of what went in. All right. Now, all that... We've got 3 functions here. You got to learn how to read a table. So we've got 3 functions which represent the y values for all of these x values. Now it says find each of the following composite functions. Now he's using a word that I don't really like. He is calling all of these down here compositions, but they're not. This right here is not a composition. Do you see something like f of g of x or g of f of x? No, that's a combination. Combinations are when you add, subtract, multiply, or divide functions. So he got a little slack on that one. This one is a composition. This is a composition. This is a composition. All that stuff on the top row, those are not compositions. They are combinations. So we are not going to do all these. Ugh, my throat hurts now. Let's do this column right here. 2 times g of negative 1. Read the table. What's g of negative 1? So that's 2 times 7 divided by, what's f of negative 2? What's the answer? Please leave 14/3. Do not change it to 3 2/3. Do not change it to 3.6 repeating. Leave it as 14/3. This is a beautiful answer. If a teacher in elementary school told you that that was a bad answer, they're wrong. It's a great answer. Now, what's the next one? H of f of 2. What in the world do I do first? I do f of 2. Remember, f is your first machine, and what goes into f? 2. And what comes out? 3. What goes into h? 3. What comes out? Negative 1. Wait, what?
What is,
F of 2. F of 2 is 3. And then h of, no, it says h of 3. It doesn't say h times 3. It says h of 3. So that means I'm putting 3 into h, which is right here.
Right, yeah. I think I'm getting it now.
Okay. Well, let's try another one. Let's try this one right here. What function happens first? F. What goes in? 3. So 3 goes into F. What comes out? 2. So this is G of 2. I can't do that again. What's G of 2? There you go. Thank you. Thank you. Do K. You do it. What's f of negative 1? 2. So we've got G of h of 2. What's h of 2? 0? Huh? What's the answer here? G of 0 is 0? I can't hear. Thank you. Negative 2. Da-da-da. I don't know where I'm looking. I don't know. All right. Now, we're going to do n. P of x is equal to the absolute value of 2x minus 3. For what values of x is P of x equal to f of g of negative 2? What do you have to do there? F of g of negative 2. Figure out what f of g of negative 2 is. G of negative 2 is 1, right? And f of 1 is 4. So I need for P of x to equal what? I need this. This is what I need. I need P of x to equal 4. Well, P of x is that bad boy right there. Now I picked this to make you work another absolute value function. Do you remember how to solve an absolute value? What numbers have an absolute value of 4? So what's under my hand has to equal 4 or negative 4. So what's under my hand has to equal 4 or it has to equal negative 4. You can solve those in your head if you want to. What do you get? Say again? This one's negative 1/2. And 7/2. Good. Good. How could you check those? Plug them in. If I plug in 7/2, what's 2 times 7/2? 7 minus 3 is 4, and the absolute value of 4 is 4. So you can always check them. Am I going too fast, or are you getting this okay? All right, next page. Do you remember the title? I think I didn't say. The title of this lesson was compositions, but numerically, we just did that. That was with the table. Graphically, that's the next piece. That's the graphs. And then tomorrow, next time you get a video, will be analytically. All right? So let's get back. Again, we're not going to do all these. Let's pick one column because none of the columns look any harder than the others. This column right here. All right, fine. G of negative 2 times f of 3. Is that a composition? No, it's a combination because all you're doing is multiplying. What's G of negative 2? G of negative 2 is 0. F of 3 is Does it matter? G of f of negative 2. What's f of negative 2? Negative 1, so I need g of negative 1 is 3. The one under that, f of g of negative 1 is f of 3, which is 3. Shoot, this is about as easy as falling off a log. All right, do this one. G of f of negative 3. You do it and I'll do it and we'll see if we get the same thing. Questions? Okay, I'll cut you some slack on absolute value. Let's do this one. If h of x equals x squared minus x, then for what values of x is h of x equal to g of f of 1? What do I need to do? Yep, let's find g of f of 1. What's f of 1? 0. And g of 0 is 2. So I need this. I will haunt your dreams if you cannot answer this one right. How do you do that? Because when you solve a quadratic, you need it to equal? Good. I will haunt your dreams. X squared minus x minus 2, they'll be nightmares. That's right, I intend to. I intend to get inside your head. Okay, how do you solve that? Aha, how do you factor it? X equals? Shoot, piece of cake, right? Here. The last piece of this is analytically. Now, the analytically is not hard either. It's a little bit longer. By the way, let me tell you this. You're going to be getting 2 homework assignments tonight. At least, but listen, at least before Friday, do a little bit on both of them. That way on Friday you know what you're doing. And then just make sure you have it all done by the next quiz, right? Okay. Yeah.
What's the next quiz?
Look on your syllabus.
Syllabus.
Use equations to find compositions. Now, listen, this is not difficult. I promise. You guys have just been blowing through the rest of this stuff. You got 4 functions there in that top box. You've got a quadratic, linear, rational function. Yeah, that one. A rational function has a variable in the bottom. You know these are linear, right? Mx plus b, y equals mx plus b. Look at number 1, g of h of 4. Yeah. So, now, yeah, these are my machines. 4 is going to go into here, and it's going to go, rah, 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 and what's going to come out? That'll be g of, plug 4 in there and tell me what you get. 3 halves times 4 is 12 halves, which is 6, minus 2 is 4. See? Now, and then what goes into G? 4. So 4 goes in here, and what comes out? 1 minus 2 times 4 is negative 7. See? See? F of negative 2 plus G of negative 2. What's F of negative 2? F of negative 2. Negative 15, I agree. Plus P of 2. P of 2. Good, negative 4. That's it. See, I told you it wasn't hard. Okay. How many tasks are there? 3?
3.
All right. Question? Task 1. You're given f of x and you're given g of x. Find f of g of negative 2. Go. Are you getting 29? Okay. Look at task 2. If there's anything that even requires any effort, it's task 2. You're told what f of x is and you're told what g of x is. Find an equation for f of g of x. Notice, it does not tell you a number to evaluate. Now I want you to think about this. What function do I do first? G of x. What is g of x? 2x plus 1. What's going to go into f? 2x plus 1. So you have your machine. You have your machine f. And what's going to go into it? 2x plus 1. And it's going to do this to it, right? So 2x plus 1 goes in, and it's going to have to growl for a while because it's going to take a little bit to do this. How do you put this into this machine? Plug what in for x? Good. So this is going to be 2 times 2x plus 1 quantity squared minus that's it. Shoot, if you can do that, you've got. No, she's right. It said equation. So it should say this equals this. Because what did I do? I didn't write an equation. I wrote an expression. Yeah, I wrote an expression. Can you do this in your head? Can you do this part in your head? Can you square 2x plus 1? If you had Seigert, you can. Especially if you had it from pre-AP, you can. Yeah. Did you really call him Mr. Stanby? To his face? Really? Two x plus 1 times 2x plus 1. 4x squared plus 4x. Good. If you cannot do that in your head, write out 2x plus 1 times 2x plus 1 and FOIL the blasted thing. You guys can all simplify that. I will not insult your intelligence and walk through that with you because you all can do that. Did you get an equation? You got f of g of x equals, help me out because I was too lazy to do it. What'd you get? 8x squared plus 2x, good, plus 1. Well done. That's it. We do okay? Yeah. Now look what it says to do here. Use the equation you just found to find this. What are you going to do? Plug in -2 for what? Plug in -2 for x, and you'll pop out your answer. One of the reasons, another reason that it's helpful for us to do this, any of you taking the ACT in October? Isn't there one in September? There's one in September, there's one in October. Juniors, if you haven't taken that thing yet, take it. You need to take it more than once. So you can, the first time you will just kind of get an idea of, okay, this is what it's like, and then you can do better next time. But please take it before you take that freebie in the spring. You getting an answer? What is it? What do you get? What's the answer to this? If you substitute in -2. 29. That's what I got. Now wait a minute. Didn't we get 29 somewhere else? Look, didn't we get 29 right here? Isn't this where we got 29? Yeah. Oh, look. It was harder that way. If you find g of -2, we did this 2 different ways, didn't we? Here, we found f of g of -2 while f and g were separate. What we did here is we went ahead and did f of g of x and then substituted in the -2. We only had to make one substitution here. But I will contend to you this is much more involved, isn't it? You did great.
Brianna Alexander.